Hi, I'm Karan from Locofy, and today I'm going to talk about how our large design models, or LDMs, are helping accelerate front-end UI development. So as builders, entrepreneurs, or product managers, the start of any project is the most exciting time. You have a vision, you have an idea, and you want to bring it to your users as soon as possible. So you work with your designers, and you come up with your first wireframe. Things are looking good at this point. You get some feedback, you talk to stakeholders, you take all that feedback, and then you come up with your mock-up. And you're pretty happy at this point. Things are looking good, your vision's almost there. But we all know what happens after this. Iterations and iterations, back and forth between designers and developers. You've blown your budget, you're way behind schedule, and it's still not something that you're ready for. The final product, after all of this, is not really what you actually wanted to build. And at this point, literally everyone wants to kill everyone. So you started with something great, and you ended up with something else. Now, here you're in a conundrum. What do I do next? Do I ship a substandard product to my users, or do I go back to the drawing board and start all over again? There has to be a better way to do this, and that is where Locofy comes in. We help take your designs to code and convert it into code, and we do it in just one click. So before I go directly into the AI that actually is powering this technology, let me just show you how it works. So, all right, giving it some time to load. All right, so we are a plugin within Figma, which is a design tool, and this is a typical Airbnb design that you can see. This would actually take a few engineers a couple of weeks, if not months, to convert into code and actually ship this out. But with Locofy, as you just saw, a single click helped convert this into fully responsive code. The idea is that you're able to now also interact with it, so it's not just something that is static, and you're able to look at the code that is actually generating the preview, as you can see here. In addition to this, we also generate components, and this helps make your entire code more modular. The idea is not to actually replace engineers, but to supercharge them so that they can actually work on high-value items, and 80% of the grunt work of the front-end UI development is actually taken care of by Locofy. Here, we also, like any AI, it's not perfect, so it does make mistakes. But we have provided the diagnostic tools to go through each and every decision made by the AI and actually edit it. So the power and the control is still with the actual engineer. And all of this is possible because of the large design models that we built. We built this in-house from scratch by training it on designs that were available. Now, the next obvious question is, another model, really? Can't LLMs actually do this? And we put that to the test, right? So let's actually see what happens when you ask the same problem to an LLM. So we did this with Gemini, and he said, hey, here's a design, here's an image, can you convert this into code? No code was generated. We just got a bunch of instructions on how to do it. Claude, same thing. No code was generated. ChatGPT was slightly better, right? We still got code, we got something, but what it actually looks like and what we wanted to build is very, very different. And the same problem given to Locofy was able to create not just code, but also pixel perfect and almost production ready. And that is basically how LLMs and LDMs kind of differ. So why do they actually differ? Large language models or even multimodal models are trained on text, on generic images, and that's what they really understand. But designs are not text and images. They are shapes, they're vectors, they're symbols. A heart icon or a home icon has a specific meaning in a design. So large design models are actually trained on this rather than just generic text, and that is why we're able to generate the code that you just saw. In a nutshell, this is basically all that is made inside the large design model. So we take designs, we have built a foundational design model using text, image, as well as the node metadata that is provided by these design tools, and we generate the embeddings and concatenate them. This becomes the backbone of all these smaller models that solve a specific task, like optimizing your designs, making it interactive, making it modular, and responsiveness. Responsiveness is basically making sure that it actually works on a desktop as well as it scales down to a mobile. So once we go from the design to the code domain, that's when we see the actual power of LLMs helping out. So we use that to optimize layer names and other code optimizations. And all of this process, which happens in one click, goes from your design to code and preview that you just saw. Let me dive a little deeper into each of these smaller modules, right? So Design Optimizer is our model to look at the structure of the design and optimize it, removing redundant groups, adding auto layout, making sure everything is vertical and horizontal, and also grouping them accurately. We use visual transformers as well as name entity recognition models to achieve this. And then we go into the next step, which is basically adding semantic meaning to your actual designs. So a design can consist of multiple things. So for example, you have autocompletes, you have inputs, you have buttons. You want to recognize all of this, but in a design, it's nothing but a rectangle. So to really understand the actual item that it is actually going to be used for, like a button is going to be clicked or a datetime picker is going to show you the calendar, that's basically what the model is able to distinguish. And not just these atomic elements, we also detect meta elements like your header, because headers have special properties, or a grid, which also has special properties. So we're able to detect this and add the semantic meaning to the design itself. Code components. So with any design, you always have repeated items. Like for example, in this case, you have a hotel card that's repeated multiple times. So you don't want to keep generating code for each item. So the idea is to use similarity detection in this case to detect similar items and then convert it into a single component and a single code base. In addition to that, we also generate the properties or the props that can be used to distinguish different instances of the same component. And then we have responsiveness. This is one of the toughest problems we had to solve. It's very subjective, but taking something that looks good on desktop and mobile and having it work seamlessly is not easy. Here, we use a hybrid approach. We use tagging and feature detection to understand the UI patterns that have been detected, and then we use static algorithms to apply the relevant responsive rules, so you go from your desktop to your mobile seamlessly. And this, in a nutshell, is basically your large design model. Once we enter the code domain, as I mentioned, we're looking at auto layer names. So designs typically have hundreds or thousands of layers. Manually renaming each of them so that they make sense is a cumbersome task, and no one really does it. So using LLMs, Gemini in this case, we pass the context of the design and the output of our LDM to make sure that it understood what each function was and come up with more meaningful names that can be used as variable names in your code, further improving the quality itself. So going quickly into how we actually train our model. So we use publicly available HTML and Figma data. We label them, and then we convert them into a proprietary design data format. This design data format ensures that we can actually scale across different design tools, not just Figma, but also Adobe XD, Penpot, and support both mobile and web apps. This is then fed into our foundational design model that looks at all three modalities, image, text, and metadata, concatenates them, and then feeds them into the design optimizer, tagging, components, and feature detection models. Now, the typical metrics that you would use for an ML solution are not really relevant in this case, or not very useful for us to understand how models are doing. So we built our own evaluator, which looks at pixel differences, but also looks at how the design is different from the preview and make sure that there's an improvement with every iteration. And finally, the inference pipeline itself is very simple. We take your Figma designs, we convert that into the design data format, the LDM inference happens along with the LLM layer names, and the combination of that is used to generate instructions, which then generates the code itself. So this is where we are today, and it's just the tip of the iceberg. We have big plans. We want to scale our LDM to go to a 2 billion parameter model and train it with a lot more data. We also want to support mobile apps and scale to more design tools. Responsiveness is another big challenge we want to solve. We believe feature detection, that is adding semantic meaning to the different UI elements, is the silver bullet here. So we want to be able to identify that and actually improve that performance there. And finally, once we enter the code domain, we want to use the power of LLMs to optimize the code further. Rather than reinventing the wheel, we want to use these LLMs to maybe add back-end logic to kind of add internationalization, comments, and also remove redundant code that might have been generated. So that's all I have for today. Thank you again for your attention. We have a booth downstairs, booth 118, so please come down if you guys want to see a quick demo. We have been in free beta for the last 3 years and just launched a pricing plan. So if anyone's interested, there's a coupon code there, and hope to see you guys at our booth. Thank you so much.